Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter periodic classification. In this session we are going to see about special names of the groups and periods in the modern periodic table. Yes, in the earlier session we have started this learning about special names given to different groups and periods in the modern periodic table. Some we have seen already, like first A group elements of the periodic table are called alkali metals. Second group elements are called alkaline earth metals. On the extreme right side, that is 18th column or 8th A group elements are called as noble gases. And last but two, that is 17th column elements are called halogens. Why they are called so also we have seen earlier, isn't it? In this session, let us continue the same. Let us learn about some more common names or special names given to the groups and periods in the periodic table. Okay, let us start this here. First among them is chalcogens. That is the 16th column elements in the periodic table. They are oxygen, sulfur, selenium, tellurium, and polonium. These elements are present in the 16th column or 6th A group of the periodic table. These elements of 16th group or 6th A period group are commonly called as the chalcogens. The term chalcogens was derived from the Greek word chalkos, which means ore formers, since they all are being found in the copper ores. So these elements are specially called ore formers. Ore former means most of the metallic elements, metallic substances are existing in the form of metal ores are existing in the form of either sulfides or oxides or selenides. So metals, most of the metals are existing from the earth crust in the form of ores. Those ores contain these metallic oxides, metallic sulfides, metallic selenides. In this form, most of the metals are existing in the earth crust. That is why these elements are considered as metallic ores. Based upon this reason, these elements are known as named as chalcogens. So 6th A group elements are called as chalcogens, and the compounds of the metals which are existing with these 6th A group elements are called as chalcogenides, chalcogenides or chalconides. Okay, in that way these elements are getting the name chalcogens, means ore formers. Most of the metals are existing in their ore form with oxides or sulfides or selenides. Got it? Next term, nicogens. In the periodic table at the right side, the 15th column elements, they are nitrogen, phosphorus, arsenic, stibbium and bismuth. Sorry, these elements are called nicogens. What are those? 15th group or 5th A group elements are commonly called nicogens because some of them, especially nitrogen, can cause suffocating or choking and stifling sensation in the body. Because of this reason, these 50A group elements are called as nicogens. What is the reason for calling them as nicogens? They cause they they produce some gases which can cause suffocation or choking or stifling sensation in the body. That is why these are called nicogens. Based upon this reason, they are called nicogens. The meaning of this word nicogen is the gases causing suffocation, suffocating, or choking, choking gases. Simply to say, choking gases, nicogens, especially nitrogen and phosphorus gases. So the most important elements of this group are nitrogen and phosphorus. So in the 50A group elements, the most important are nitrogen and phosphorus. We know nitrogen is a diatomic gas which is existing in the major quantity in the atmospheric air, isn't it? nitrogen is the most abundant atmospheric gas. Out of total atmospheric gases, 78% is nitrogen itself, isn't it? So as it is, we can say it is a principal component of atmospheric air. So in that way, it is an important gas. And even if you see phosphorus, the second element in this group, phosphorus is also very essential in all big, as it is one of the forms of the all living things. In the bones and the muscle, it is existing in the form of phosphates. So phosphorus is one of the essential known forms of life. So in this way, these two are were most important elements from this group. These 50A group or 15th A group elements are called as nicogens because they produce gases which cause choking or suffocation or stifling sensation in the body. Because of these reasons, they are called as nicogens. Next, coinage metals. So, in the 11th column of the modern periodic table or 1B group of the modern periodic table contains some metals which are called as the coinage metals. What are those? The elements of group 11 or 1B are called as coinage metals because they are used in minting coins. Yes, nowadays we are using coins. In the earlier days, mostly the coins were made by using these metals only. So, based upon that reason, they are called as coinage metals. The main reason for that, the main reason for using these coins for minting coins is they are highly malleable. Of course, we know all the metals are malleable. The one of the properties of metals is malleability. But these metals of 1B are having especially high malleability and ductility. What is malleability here first of all? Malleability is one of the properties of metals by which they can be beaten into thin sheets. Almost all the metals they exhibit this property of malleability. But 1B group elements or first B or 11th group elements, they have high malleability. They can be beaten into very thin sheets. And one more special property of these first group elements is 1B group elements is high ductility. What is meant by ductility? The property of metals by which they can be drawn into thin wires. Almost all the metals they exhibit this ductility property, isn't it? Of course, few exceptions. But here, these 1B group elements are having high ductility. They can be drawn into very thin wires. So these are special properties. Because of these special properties, these elements or these metals present in this 1B group are used for minting coins. And not only for this, they are used also for making of ornaments. Isn't it? Most of the ornaments are made with silver and gold because these are having high ductility, and even copper also used, of course. Okay, because of these reasons, they are used in making of ornaments. They have ability to get into converted into thin sheets. So because of these reasons, they are used for minting coins and in making of ornaments. That's why they are called coinage metals. Okay, next, metalloids. Some of the elements present in the periodic table, they can exhibit the properties of both metals and non-metals. Those elements which can exhibit the properties of metals as well as non-metals are considered as metalloids. If you see the elements shown in the yellow color here in the modern periodic table, in the staircase position in the periodic table are called as the metalloids. There are totally 7 elements which can exhibit the properties of both metals as well as non-metals. These elements are called metalloids. So these are present in the third A group, third A to 7th A they are spreading. If you see nothing but 13, 14, 15, 16 and 17 groups they are present. See, boron is present in the third A group or 13th group. Silicon and germanium are present in the 4th A or 14th group. And Arsenic and stibbium, they are in the fifth group, nitrogen family. And tellurium is present in the chalcogens group. And astatine is in the halogens group. So these seven elements can exhibit the properties of both metals as well as non-metals. That is why these seven elements are specially called as metalloids. Okay, some of them means like a silicon or semiconductors. They can carry electrical charge, so they are very useful for making of electrical appliances like calculators and computers. So some of these metalloids are semiconductors, so they can conduct electricity through them. So this semiconductor property of these metalloids like silicon made them very useful. Mostly silicon is used in the almost all the electronic appliances, isn't it? For making of these electronic chips, mostly they use this silicon only because it is being semiconductor. Okay. Next, representative elements. The elements present in the extreme left side two columns. What are those two columns? 1A group and 2A group. Along with this, the last six columns elements except noble gases. Here, third A, just now you have seen third A group elements to seventh A group elements till chalcogens. So here if you see boron, third A group, carbon fourth A, next nitrogen fifth A, next oxygen 6A and seventh A fluorine. So these groups elements, first A to seventh A, these all groups of elements, totally 7 groups elements are considered as representative elements. Group A, groups 1A and 2A on the left hand side and 3rd A through 7th A on the right hand side except noble gases. So this extreme right side portion 8 to 6 columns except noble gases, remaining 5 columns, and the extreme left side portion with 2 columns. These all elements together considered as representative elements. Okay, so why they are called so? Why these are called representative elements means if it is observed for the first group, these are 1A, 1B to 7th A. These all elements, if the electronic configurations are observed, they have incomplete outermost shells. We know the element with 8 electrons in its outermost shell will be more stable, just like the noble gases. But the elements which are having incomplete outermost shells, incompletely filled outermost shells, will be unstable, means that they are not stable. These elements will try to become stable by getting 8 electrons in their outermost shell. So in this getting, they may gain electrons or they may lose electrons, or often they may share electrons. That we are going to learn how do they lose or share electrons in the next classes. Now here, as these elements are having incomplete outermost shell, they will be more reactive. That means they will try to become stable always. In that trying, they'll be more reactive and they'll be ready to react with the other chemicals. So because of this reason, most of the chemical reactions are because of these representative elements. These are 1A to 7th A group elements. That is why especially they are called representative elements, because these are representing most of the chemical reactions because of their high reactivity or low stability. If you see first group elements, let us see here one element is sodium. If you see configuration of sodium, we know its atomic number as 11. So configuration will be 2 comma 8 comma 1. Means how many electrons are there in the outermost shell? There is only one electron. Now can we say as this sodium is stable element? No, because there should be 8 electrons for the stability, but it has only one electron. So sodium is a non-stable element or highly reactive element, because it will be very ready to gain or lose this one electron to become stable. So it is a more reactive element. it will be always participating in the chemical reactions to become stable. If you see one of the elements from this side also, if you take fluorine, atomic number of fluorine we know as it is 7. If you read configuration 2 comma atomic number of fluorine is 9, and if you read the configuration 2 comma 7, so there are 7 electrons in its outermost shell. Is this element is said to be now stable? No, because it is having 7 electrons only. To become stable, there should be 8 electrons. So this fluorine element is also will be always ready to combine or to participate in the chemical reactions. By that, it will get 8 electrons into its outermost shell by gaining one more electron. In this way, all these elements present in these groups 1A to 7A are having incompleteness in their outermost shell, and hence they will try to become stable always, and they will participate in the chemical reactions. Because of this reason, these elements are termed as representative elements, because these are representing most of the chemical reactions because of their reactivity or activeness. Got it? Next. Next, transition metals. So the elements present in the middle 10 columns, like between these 1A and 2A and this third A to 8th A, means the B subgroup elements. Here third B, let us see third B to 1B. Here third B is started, and fourth B, fifth B, sixth B, seventh B, and these three columns together called as 8th B, and first B, second B. These groups, these 10 columns elements are considered as the transition metals. Let us see here. The elements located in group 3 to group 12 of the periodic table are classified as transition metals. Let us say in June this. So we can say this is third B, this is fourth B, fifth B, sixth B, seventh B, and we know these the three columns elements all together considered as 8th B group elements, isn't it? Now here it is 1B coinage metals, and this is a second B zinc group we call this. So in this way, these all elements present in these 10 columns all together considered as transition metals. The transition metals are ductile, malleable, and can conduct heat and electricity through them. These are the properties of transition metals. Why they are called so as transition metals? Because if you see at the extreme left side of the periodic table, highly reactive metals are there, and at the extreme right side, except noble gases, highly reactive non-metals are there. No, so we can say the metallic properties are being transmitted from the properties of the elements are being transmitted from metallic to non-metallic through these elements. As these elements are transmitting the properties from high reactive metals to high reactive non-metals, these elements are said to be transition metals. These are in between the highly reactive metals and highly reactive non-metals. That is why these are called transition metals. What are those transition metals? B subgroup elements present in the middle of the periodic table, 10 columns or 8 subgroup Bs. Got it? Next, lanthanoids. The elements which are to be in this position in the periodic table, they are written down at the bottom of the periodic table in one horizontal row. These elements are called lanthanoids. The elements which are present along with the lanthanum or which are present after the lanthanum are called as lanthanoids. The lanthanoids are the elements with atomic numbers 57 to 71. These metals are often called rare earth elements also, because these lanthanides are available in the rare quantity in the earth atmosphere, in the earth crust. That is why these are also called rare earth elements also. They are called lanthanoids because they exhibit similar chemical properties to lanthanum. Yes, these elements are present after the lanthanum, and these all elements exhibit similar properties to that of lanthanum. That is why these are called lanthanoids. And one more point you have to remember here is they all have same position in the periodic table. This is down to the yttrium, they have one position. All should be kept in this place only. These all 14 elements. These are 15 total. If they, including lanthanum, they become 15. So these all 15 elements should be kept in this position. Then this horizontal, that is sixth period, contains totally 32 elements. So to make it convenient, these 14 elements are written down to the periodic table. So the elements which are after the lanthanum are called as lanthanoids. Generally, in some periodic tables we see lanthanum will be written here. Remaining elements from cerium to lutetium are written down in this horizontal row. These elements, these 14 elements are called lanthanoids. These all elements will show or will exhibit similar properties to that of lanthanum. That is the reason they are called lanthanoids. Okay. Next, actinoids. In the just like the lanthanoids, one more horizontal row is written down to the lanthanoids in the periodic table. That is actinoids. We can say these also as the elements after actinum are called as actinoids. Okay, actinoids are the elements with atomic number from 89 to 103. They are named after the first element in the series actinum. Yes, the element in these actinoids, the starting element is actinum. So based upon its name, they are named as actinoids. In the lanthanoids also in the same way. The starting element is lanthanum. So based upon its name, they are called lanthanoids. The actinoids group includes mostly man-made elements, with only a few exceptions such as uranium and thorium. Yes, we say out of these 118 elements, around 92 elements are naturally occurring elements. The remaining elements are said to be man-made elements or synthetic elements, isn't it? So most of these actinoids are synthetic elements, except a few like uranium and thorium. Remaining all elements are man-made elements or synthetic elements. They are derived from the already existing natural elements in the laboratory. That's why they are called man-made elements or synthetic elements. So these all are given in the one position in the periodic table, that is down to lanthanum in the periodic table. In the seventh period, they are given a one position. These all 15 elements should be positioned in this. Often in certain periodic tables, we see actinium is written here. The remaining elements from thorium to lawrencium are written down in this actinides position. Okay, this is about actinoids. The lanthanoids and actinoids together called as inner transition elements. We are telling these elements are given two positions in this periodic table like this. In the third B group. That is why these are written separately from these transition elements. That is why they are called inner transition elements especially. Okay, these are written and written separately down to the periodic table. These are extracted from the transition elements. That's why they're called inner transition elements. Lanthanoids and actinoids together called as inner transition elements. Next, that's about the groups classification and the groups special names. Now let us see some elements from the periods with special names. Now the typical elements. The third period elements of the periodic table are called typical elements. What are third period elements? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These are present in the third period of the periodic table. They are called specially typical elements. The elements of third period are called typical elements. Why? Because they summarize the properties of their respective groups. So by taking the third period element as standard, we can summarize the properties of that particular group. Based upon this reason, they are called typical elements. Let us take an example to understand this. For example, if you see sodium is a third period element of this first group, 1A group, or this is the typical element of 1A group. So by taking the chemical properties of sodium, we can summarize the chemical properties of these first A group elements. Because if we take the first element of this first period, what is the first element? Hydrogen. We cannot summarize the properties of this group by taking hydrogen as standard. Because if you see hydrogen, it is a non-metal, isn't it? Whereas the remaining all elements are metals in this group, the two highly reactive metals, except hydrogen. Hydrogen is a non-metal. And if you see, hydrogen is a gaseous element, whereas the remaining all are solid metals. So because of that reason, hydrogen cannot be taken as standard for summarizing the properties of these first A group elements. If we see next also, second period element, lithium. Lithium also having some exceptions from the remaining elements. It is very soft metal, and there are some chemical properties also, physical properties and chemical properties also slightly variant from the remaining elements. That is the why reason sodium is considered as a standard element for summarizing the properties of 1A group elements. That is why sodium is called typical element. In the similar way, if you see the third period element of second group is magnesium. Magnesium is considered as a typical element because in these elements of the upper portion there is a beryllium. But beryllium, even though it is a metal, it will show certain different properties. It will form only covalent bonds. It cannot form ionic bonds. It cannot lose its electrons in the valence shell as it has only two shells. So these properties we are going to learn in the further classes. So, but magnesium is taken as a standard for summarizing the properties of these second A group elements. Because of this reason, this magnesium is said to be typical element. In this way, the third period elements of periodic table are considered as typical elements. Okay. Next, bridge elements. The typical elements of third period are also called bridge elements because the division between the two subgroups of a group will be started from this third period. After this start third period, the division between the two subgroups of a group A and B will be started. That is the reason why these third period elements are also called as bridge elements. In second group, magnesium acts as a bridge element. In first group, sodium acts as bridge element. Say here, in the first A group, these elements are there. In the first B group, these elements are there. So after sodium, after the third period element sodium, this division of A and B subgroups is started, isn't it? That is why the sodium is said to be bridge element between these two A and B subgroups. In the similar way, if you see second group elements, this is a second A group and this is second B group. After third period in magnesium, the division A and B is started. A and B subgroups is started. So this magnesium is called bridge element between these two subgroups. Not only this, the properties of the bridge elements are somewhat mixed properties of the elements of two subgroups A and B. For example, if you take magnesium, it will be having the chemical properties or properties similar to 2A group, that is alkaline earth metals, and it also shows some similar properties with second B group, that is zinc group. So in this way, they have similarity in the chemical properties between these two A and B subgroups. For this reason also, these third period elements are called bridge elements. Okay. Next, diagonal relationship. In the periodic table, an element of a group in second period will show certain properties similarity with the next group third period element. This relation is said to be diagonal relationship. What is that? For example, if you take lithium of first group, we know in the 1A group, the second period element is lithium. For this, the next group next period element, or the next group third period element is magnesium. So between these two, there is some similarity in the properties, and these two are positioned in the diagonal position in the periodic table. So this relation between these elements is called diagonal relationship. One element of a group present in the second period will show certain similarities in the properties with the next group third period element. So these two elements will be positioned in the diagonal relation. That's why this relation between these two elements is said to be diagonal relationship. In the similar way, beryllium of second group, that is second period. Next, third A group, third period element is aluminium. These two will show certain properties similarity. This relation is called diagonal relation. And boron with silicon, carbon with phosphorus. So these elements will show certain similarity. This relation is called diagonal relationship. Okay, these are certain common names or special names given in the groups and periods of the modern periodic table. Did you understand? Right. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates and recorded videos.